Hello everyone, in this video we'll see binary search trees in order traversal. There are three ways of traversals are there: in order, pre-order and post-order. And in this video we'll see what is in order traversal, and in this tree we'll traverse in the in order form and we'll print the nodes. And this is a perfect binary tree I have with all of the root node and child node, parent node, everything. Okay, this is the node structure. I have node with the data and left and right pointer. This is a typical binary node. Okay, what this in order traversal is? This is one of the three traversal methods. So this is the snippet of those code, exactly code. I'll explain you what it is, and you have to consider these three things. In the node we have these three properties like left, right and data. Data is the actual value and left, right are the pointers in the binary node. So I have this format or the direction left, data, right. This is called the in order. Here this data node, where the data node is, using that only these kind of traversals are there. The ultimate thing is you are going to access the data. So if the data is between the left and right, between, so the middle data is there, this is called in order, which means in the order it is inside. So this is in order. If it is before this, this is pre-order. If it is last, then it is a post order. So this is the way you can easily remember this in order, pre-order, post-order algorithms. You must not confuse with this against the BSTs. This is a binary tree, but BST traversal also is the same algorithm, but it carries some properties with the in order and pre-order and post-order. But this is just binary trees. This is not a binary search tree, but the algorithm is exactly same. So okay, now I have this in order, so my data will be in middle. Okay, what I'm going to use here is I'm going to use a recursive method to write the algorithm. Okay, what this code is, I have method called InOrder. I'll have some the root node. I'll given this one as a root node to my code. If the code is if the node is null, then I'll return. I'll not proceed with any of these steps. So okay, now I have value when one is passed in this one. Okay, now I need to go to the left, because first we have to access the left and then data and then right. This is the in order traversal. So I'll access the left and I'll print the node and I'll go to the right one. Okay, now we have these three examples, various trees. All are those are binary trees only. This is sometimes here absence of some nodes are there, but that's okay. We'll use these trees to figure out what's the in order traversal is in our code. Okay, I have this code written. First I have to travel left and then print the content, and then I have to travel to the right. Okay, now I here only this 10 is there, so what I do is I have to travel left, and then here also some node is there, then I have to travel left. This is a recursive call. Here this line is a recursion call, so that's the reason we are keep on going inside. So if the recursion means again it will go back here, so we are going to repeat the operation same. Here the reason we use the recursion is we are going to do the same operations but in the below level of nodes. If you're using recursion, you must know when you have to stop the code. That's the first condition, because if you just started the recursion and you just ended it as an infinite loop, then it will go, so it will corrupt all the codes. So here in this one, you're going to trigger this left node and again it will go. So that's the reason we go here and then I'll go again to the left. So I didn't print that because that's in the next one. Okay, now I'm in 40. So 40 I'm looking. This is not a null and it went deeply inside, and it's checking for the triggering the next recursion called, and here the node nothing we have, it is true or null. So it they returns from the stack position, and here the next statement is printing. So that's the reason we deeply go inside and then print the content and then come back. Okay, here once we have printed the 40, there is 20. So the next statement is the stack trace, it will be 20 only, and then we'll go here. The next statement is write, so 50. Once that, it will come to the 10, so 10. Here next it will be going to the right position, and here when it goes to the right position it will ask for the right, because once it goes to the right position again it goes to here and then comes again, it will trigger the left side. So 60, once 60 is there, it will print 30, and the next it will print 70 and then returns to the actual code. So this is how the InOrder Traversal works. So what our output will be is, first it will go 10 to directly to 40, and then I have our this print statement. So this subtree is over. So what's next is 20 and then 30 and then 10. So here it is 50, so 50, then 10 and then 60 and then 30 and then 70 and then it will return. Okay, now we'll solve the same thing with the help of one stack. So internally the recursive program will be maintained in form of program stack. So we'll see the same example, the InOrder Traversal with the help of stack. So initially I have given this now 10, and I have this output of InOrder Traversal, the manual operations that we did with the help of recursion calls. And when recursion calls are there, this example snippet you can consider: if node is null, exit, then travel to the left side and print the data, and then travel to the right side. Okay, initially I have given this node 10, so I have a program stack. Here what I do is I have to do the left and then print the data and then write. So initially I push this 10, then I have to go for this 20, travel to the left side. So left side what I have is 20, and I'm checking the same operation whether it's having left or right. So I have 40, so I have 40. So I'm looking the same in next operation for left or right, nothing is there, so I'll print and take it out. So here I printed 40 and I take it out. Next operation is I have to print the data. My left side traversal options are done, then I have to print the data. So when I see here what's in the stack at top is 20. So here what I'm doing is 20, and then I'm checking for the right side. So right, anything is there? Yes, 50 is there, so 50, and then I'm checking the right or left, nothing is there, so print it and come back and delete it. Okay, now the operation with the 20 right left are done, so take it out and delete it. Okay, now I have 10, so my left operations are done and I have print statement. So what I do is 10, print it. I have pending right side operation, so I have 30, so 30 is added. Then I have to check for the left side, so 60 is there, so 60, and I'll check the same thing for right or left is there with 60. No, it's not there, so print it and delete. from the stack. Next, I'm coming here, 30 is there, so print it, the statement, and travel the next right side. So 70 is there, so I add the 70. Yeah, 70 is there, and there is no right or left, so you can print it and delete it. And here also 30 is right and left are done, so I'll delete it, and 10 also right and left are done, so delete it. Okay, now the output of the in-order traversal with the help of recursive calls and with the help of a stack is exactly same. So this is how we have to use the stack, and internally the computer uses for the stack operations, and then it will return. Okay, so okay, now we have this tree. We'll do the same thing and see how it is work. First I have 10, here I went, then here also I went, because I have only the left, so it will travel to the leftmost, and first it will print the 40, and then 20 it will print, and then 10, and then it will comes to the right side, it will check for first left, because we wrote this left at first. So here it will come, and then 60, and then 30. So my answer will be first 40, then 20, then 10, then 60, then 30. Okay, so okay, now we'll see in this example. First we'll have given this node, and it will go here. Here nothing is there, so it will print the content, so it will be 20, and then right it goes again, it sees anything is there, no it is not there, so 30, and then again it goes here, yeah I have something on left, so 60, and then 50, and then 70, and then return to the 10, and here nothing is there, so it will come out of the program. Okay, first I'll write, how do I write this? First 20, then 30, then 60, then 50, and then 70, and then 10. Okay, this is my answer. Here you have this three outputs. So, okay, we'll quickly jump to the programming, and we'll see how these output and this in-order traversal we can code. Okay, let me just erase this content. Hope you understood this problem and solution, how we are traveling in each trees. Okay, now we back to Visual Studio Code. Here I have this node class, and it has some public properties called int, right and left, and I have constructor with the parameter x, which carries the data, and initialize that left and right as a null. Okay, I have these three trees, this first one, second one, and third one here in this format. Okay, now I'll just explain this. We have node pointer with the new node class, so I have left and right 20 and 30. So here left 20 and 30 will be there, 20 and 30, and for 20, 40 and 50 are there. So node side 40 and 50 are there for nodes left. Okay, and for nodes right I have 60 and 70. So here 60 and 70 are there for nodes right. Okay, I should get this answer. Okay, for second tree, nothing here. These two nodes are gone, so I just removed two lines. This 50 and 70 is removed from these lines. Okay, the next is I have this 10, 10's right, 10's left is 20, so left 20, and the left's right, so it is 30. Left's right means this node. This is left, the left's right. So on the left's next right is right is 50, and then I have 60 and 70 for right and left, these two nodes. Okay, I have this structure. So our InOrder traversal is nothing but we can write here as a void InOrder. There must be a root or node as you can wish. You can write if this root equal to null, we have to return. Then we have to first root of, have to go for the left side, and then see out root data, and then InOrder root right. That's it. You can call it with the arrow operator InOrder, and you can pass the same node here also. You're passing the same node, and in this line also you're passing the node as y. Okay, my InOrder traversal is ready. First here I'm checking for the root is null or not. If it is null, return, or else we'll trigger from the left side, and then we'll print the content, and then we'll trigger at the right side. Okay, we'll run the code, format the document, we'll run the code. Okay, here this is the data I got. Okay, here we'll check 40 20 50 10, 40 20 50 10, 60 30 70, 60 30 70. Then is 40 20 10 60 30, 40 20 10 60 30, and then 20 30 60, 20 30 60, 50 70 10. Okay, my all test cases are passing. Okay, this is how we have to do the InOrder traversal. Okay, thanks for watching the video. Hope you understood the problem and solution, and we'll meet in the next video.